Alright everyone, here's your lesson on reducing fractions. Now to reduce a fraction, all you have to do is divide the numerator and denominator by the same exact factor. That's it. Keep dividing, keep going until the number 1, you're not going to get a number 1, but until 1 is the only number that is a common factor to both numbers. So let's go ahead and jump right into some examples here. 24 30ths. So let's think of a number that divides into 24 and 30, and that would be 2. You're probably thinking of another one, but let's start simple here. 24 divided by 2 is 12. 30 divided by 2 is 15. And I can think of another number that divides into 12 and 15 besides 1, so let's try 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And there's your answer in lowest terms, 4/5. Now there's more than one way to do this. Like I said, you probably were thinking of a different number at the beginning, and if you did, that's great. Maybe you were thinking of 6. Divide by 6. 24 divided by 6 is 4. 30 divided by 6 is 5. And you still get 4/5. It doesn't matter. 6 was a good number to use because that is your GCF. We haven't talked about GCF yet. That's something we're going to get to later, but it's good to know that that's the greatest common factor. Here's another one, 56 and 64. And let's say, again, let's say you can't think of a big number that goes into it. And with them both being even numbers, you can always fall back on 2. Divide by 2. So half of 56 is 28. Half of 64 is 32. And let's keep doing that. Let's divide by 2 again. 28 divided by 2 is 14. 32 divided by 2 is 16. And those are 2 even numbers, so we'll divide by 2 one more time. 14 divided by 2 is 7. And 16 divided by 2 is 8. So you got 7 eighths. There you go. Now you might have been thinking of, at the very beginning of this problem, you might have been thinking of, well, why don't I just divide by 8? And that would have been a great choice. 56 divided by 8 is 7. 64 divided by 8 is 8. That's one step right there versus a few more steps up there. It's not that big of a deal, but if you want to do things quickly in math, yeah, you might want to use the largest factor that can possibly go into both, the greatest common factor. Okay, this one, let's try to think of a big number that divides into 36 and 60. Let's see, how about 6? Let's try that. 6 has got to be the biggest, right? 6 has got to be the biggest. 36 divided by 6 is 6. 60 divided by 6 is 10. And is that in lowest terms? Well, it doesn't look like it. I have an even number on top and I have an even number on the bottom, so we better divide by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. 3/5. Now let's take a look at the numbers that we divided by here. We divided by 6, and we divided by 2. Now 6 and 2, if I were to multiply those make 12. So what if we divided by 12? Let's try that. 36 divided by 12 and 60 divided by 12. Those are both divisible by 12. And 36 divided by 12 is 3. 60 divided by 12 is 5. And guess what? We get the same exact thing. We get 3/5 and 3/5. 9 25ths. All right, let's look for some numbers. There's got to be some numbers that divide into 9 and 25, right? Let's divide by 3. And let's divide this number by 5. How's that sound? If that sounds like a good idea to you, you are incorrect. This is the exact wrong way to reduce fractions. You cannot reduce the top number by 3 and the bottom number by a totally different number. That does not work. That is not allowed in fractions. So what do we do? Let's see here. Does 9 divide into both? No. 9 divides into itself, of course. 9 does not divide into 25. It divides into 27. So that didn't work. How about 5? Because I know 5 divides into 25. Will that divide into 9? And no, that would be a negative. That does not divide by 5 either. So what does that mean? That means this problem is already in simplest form. You cannot reduce 9 over 25. That will happen from time to time. You'll run into a fraction that just cannot be reduced, and that's okay. Okay, here's another one. All right, we have even numbers, so let's just try the old standby, dividing by 2. Dividing by 2 is never a bad idea. So half of 72, I know, is 36. Half of 126 is 63. See? Half of 12 is 6. Half of 6 is 3. So 36 over 63. All right, let's keep dividing. And let's try to think of another number besides 2. Well, we have to use something besides 2 because the bottom number is odd. So let's try, in this example, 9. I know 9 divides by 36, and I do know that 9 divides into 63. So 36 divided by 9, 4. 63 divided by 9 is 7. There you go, 4 sevenths. You got it. Here's another one. We have 50 over 175. Now these numbers are both clearly divisible by 5 because they end in a 0 and 5. So let's try dividing by 5. 50 divided by 5 is 10. 175 divided by 5 is going to be 35. And let's keep going. These are divisible by 5. 10 divided by 5 is 2, and 35 divided by 5 is 7. So there you have it. There's 2 sevenths right there. What else could we have divided that by? Well, let's look at what we divided by here. We divided by 5 twice. So I'm betting that 25 would have been a viable option. And 50 divided by 25 is 2. And 175 divided by 25 is 7. 7 quarters is $1.75, right? 2 sevenths. There you got it. 51/87. Did we give up on this? This does not look like it's reducible. But don't just look at it and go, I can't reduce it. Always do your due diligence and check out all the factors. 2 obviously will not work. They're both odd. So don't forget that 3. 3 is the most forgotten about number. Okay, so let's divide by 3 here. Let's see what happens when we divide by 3. Now 51 divided by 3. Now I'm doing my math probably on a separate piece of paper, checking my division. But 51 divided by 3 is 17. 87 divided by 3 is 29. And that's it. You cannot reduce it anymore. 17/29. Okay, so that does it for your lesson on reducing fractions. Please go back and review your notes if you had any difficulty with anything. Please ask me questions in class if you're confused about anything I covered. And I'll see you the next time. Take care.